Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the October-November 2021 this is the Cambridge International A-Level Mechanics paper 4 variant 2 from the 9709 syllabus. And this question here is about a few different things. One of them is dealing with SUVAT, friction, inclined planes, momentum, lots of different things here. And this is one of the questions, I think part B was one of the questions which was, very, very few students actually managed to get it right. There's a bit of a twist to this question. So we're going to go through this question. One of the students has requested me to answer it. So I'm going to take my time and go through it in a comprehensive way, hopefully. So here we have to deal with these questions. So it says particles P and Q have masses m and 2m kilograms respectively. Okay, the particles are initially held at rest 6.4 meters apart from each other on the same line of greatest slope on a rough plane inclined at angle alpha to the horizontal. So on the same line of greatest slope. Okay, what does that mean? We just the same line of greatest slope. Okay, so basically just imagine we were looking at this slope from this angle over here. Okay, we're looking at it from this angle over here. Then we would see in front of us something that looks maybe like this with a bit of a 3D kind of tinge to this. So it looks something like this. Now what it means is P and Q are directly above each other. The 6.4 meters here is going straight up the slope. It's not like at an angle like this. It's not 6.4 meters at an angle. It's the closest distance between them on this slope. Okay, so it's like this as opposed to that being 6.4 meters. 6.4 meters from here to there, the shortest distance it can be on the slope. That's what it means, the line of greatest slope. That's basically what it means. Okay, inclined at an angle of alpha to the horizontal, where sine of alpha is 0.8. Okay, the sine of alpha is equal to 0.8. Now, I like to keep my angles in exact form. My sine, the ratios of angles in exact form. Now, 0.8 is the same as 8 over 10, which is the same as 4 over 5, which is a nice number to have. So I'm going to take sine alpha as 4 over 5. And the reason being, because now I can find cosine alpha very easily. So if this is alpha, and this is a right angle triangle, if we draw it inside a right angle triangle, and this is alpha, the sine of alpha would be opposite over hypotenuse. And the adjacent side would be 3, 4, 5 triangle. 5 squared minus 4 squared, 25 minus 16, 9, square root of 9 is 3. So the cosine of alpha, therefore, is going to be equal to 3 over 5. That gives us some nice exact values for the sine and cosine of the angle. We don't actually need to know what the angle is, but we need to know the sine and cosine of the angle when we resolve the forces later on. Okay, of a rough plane. So we have a rough plane, which means we have friction. Okay, inclined at an angle of alpha to the horizontal, where sine alpha equals 0.8, we just mentioned that now. Particle P is released from rest and slides down the line of greatest slope, as we mentioned before. Simultaneously means that at the same time that P is released, particle Q is projected up the same line of greatest slope at a speed of 10 meters per second. So they're heading right towards each other. This has been released with a speed of 10 meters per second up the slope. And this has been released with a speed of 0 meters per second down the slope. The coefficient of friction between each particle and the plane is 0.6. So the coefficient of friction is called mu, which is 0.6. Okay, so it's a rough plane, so there's going to be friction here. Okay, friction is going to act. It says, show that the acceleration of Q up the plane is negative 11.6 meters per second squared. So we have to focus on Q now and look at the forces acting on Q in order to find what the acceleration is of Q. So I'm going to take the particle Q and I'm going to consider the forces acting on this particle. So the forces acting on this particle, remember Q is heading up the plane at 10 meters per second. Its initial speed. It's heading up the plane. It's moving up the plane. So the forces acting on Q, of course, are its weight. That's the first one I can think of. Okay, you're going to have its weight. And you're also going to have the reaction force That's always there when an object and a rough surface are in contact. Well, any surface is in contact. But what we also will have will be the frictional force. Now, as this is moving up the plane, friction is always trying to oppose the motion, so the frictional force will act down the plane. So this will be the frictional force, and as this object is moving, the frictional force has reached its maximum possible value, which is called F max. So F max has been achieved here because it's moving. And we know that F max is equal to mu times R. That's what we know. So this is the weight, which is 2 mg, because the mass is m. And this is the reaction force. So these are the forces acting on this object. Now, if I want to consider and try to find the acceleration, I have to resolve the forces acting in the direction of motion and also perpendicular to the direction of motion. So I have to resolve the forces, so I have to consider what this angle here is. So I can resolve the weight parallel and perpendicular to the plane. So I need to consider this angle here. Now this angle is always going to be the same as alpha. Okay, and the reason being is as follows, just in case you're not sure. As I said, I'm going to make this a comprehensive video to make sure that everyone understands what's going on. So just let me just continue this line across. Now, this is the angle to which the plane is inclined. Okay, now if we consider this big triangle over here, okay, and this little triangle over here. Okay, so I'm considering this triangle over here. Okay, I'm considering this big triangle here. Okay, this big triangle here, and I'm considering this triangle over here. Okay, now if I consider this big triangle, okay, let me just get rid of this thing here. So we're gonna, now I know that this angle in this little triangle and in this little triangle and the big triangle is the same in both of them. I know this is a right angle. I also know this is a right angle. So if I'm considering the big triangle, okay, so if I'm considering the big triangle, this is alpha and this is a right angle. This is the big triangle. If I'm considering this little triangle here, which is like this one over here, now this is the right angle. Now this angle in this triangle, this angle in the big triangle, and this angle in the small triangle are the same. So these are the same angles. These two, they're equal to each other. Okay, this is the right angle, and this is also a right angle. So if this is a right angle and this is the same as this is a right angle, this is the same as this, then these two angles must be the same. So this angle here must be the same as alpha from similarity by angle. So this angle over here is going to be alpha. The angle over here is going to be the same as that by similarity. Because this small triangle and this big triangle, they're similar triangles. This one has a right angle here and this angle, and the small one has a right angle here and the same angle. So the third angle in both of them must be the same. So the third angle here is alpha, so that must be alpha. All right, so this is a little proof of why the angle there is alpha. Okay, I've explained it with a bit more diagrams in other places. If you would like to check that on my inclined plane playlist, you can do that. Okay, so here we have the angle alpha. So now we want to resolve the weight parallel and perpendicular to the plane. Okay, so I'm going to just draw the resolved force in a slightly different color. So I'm going to take the weight. If I resolve the weight perpendicular to the plane in this direction here, sorry, parallel to the plane in this direction here, I have to go away from this angle that's given. I have to go away from the alpha. I'm talking about this alpha, the angle to which this is inclined to the plane. All right, so this angle here, okay, this angle here, this resolving the force away from alpha, away from the angle alpha given, that's going to make me have sine. So that's going to be 2 mg times the sine of alpha. Going away from the angle is sine. The reason being is because it's like we're finding the opposite side. If you think about it, okay, it's like we're finding the opposite side. Okay, so we're going away from the angle, all right, and we're trying to find the side that's opposite. 2mg sine alpha, going away from the angle given. Okay, so, sorry, I'm talking about this side. Think of it like this. This is the opposite side. So we're going away from the angle given. Okay, so we're looking at we're trying to we resolve the force in this direction. So it's going to be like opposite. And so that's 2mg sine alpha. And if we want to resolve the forces in the direction going into the angle, so I'm going to take this force, the weight, and I'm going to resolve it in this direction there. So this is the weight. I'm going to resolve it going into the angle. I'm going into the angle now. Okay, so if I resolve it in this direction into the angle, then I'm going to go through the angle, and it's like I'm finding the adjacent side. This is the opposite, this is adjacent. So I'm going to use cosine. So this will be 2mg times cosine alpha. So I resolve the forces parallel and perpendicular to the plane. Now, I can think about, let's resolve the forces now perpendicular to the plane. So I have R is equal to 2mg times cosine of alpha. Okay, and if I resolve the forces parallel to the plane, now it's moving up, so I'm going to resolve this way as positive because it's moving up the plane. Now the only forces acting up, well, there's no forces acting up, they're all acting down parallel to the plane, so they're both negative. So you have minus 2mg sine alpha minus F max. And that's equal to the mass times acceleration, because it's not in equilibrium here. In this sense, it's in equilibrium. Why? Because it's not moving perpendicular to the plane. But in this sense, it is, there's a resultant force. So it's going to be F equals ma. The resultant force, as we know, is mass times acceleration. So you're going to have the mass, which is 2m times a. And our objective is to find a. Okay, now, we know F max is equal to mu r. Okay, so we can now put that value in here and continue. So we have 2 times m minus 2 times m times g times sine alpha. As we learned, sine alpha is 4/5. And mu is equal to 0.6. So as a fraction, that's going to be 6/10, which is 3/5. So I'll leave it as a fraction for now. So we have minus 2m times 10. So I'll say minus 20m. Minus 20 times sine alpha, as we said, was 4/5, was it? Yeah, 4/5. Minus 20 times 4/5 times m. I've used a g here. G is equal to 10. Minus F max, which is mu r. Now F max is equal to mu r. So it's 3/5 times r, which is, this is going to be times, that's 20 times cosine alpha times n. Cosine alpha is 3/5. So it's 3/5 times 20 times another 3/5. This is from mu and this is from cosine alpha. And that's times m is equal to 2ma. So we can cancel out the m straight away in every term. Okay, I can cancel out the 2 with these two 20s, divide everything by 2. So we'll end up now with minus 40/5, which is minus 8. Okay, minus, and that's going to be minus, let's see, this cancels with that. Minus 6/5 equals a. So you're going to have, no, that's minus 6, sorry. It's minus 18/5. Minus 8, that's 3 times 2 times 3, that's 9 times 2, that's minus 18/5, sorry, equals a. So a is going to be, let's work that out, you're going to have minus 8 minus 18/5. which gives you minus 11.6 meters per second squared, which is what we had to show. Okay, good. So there we have the answer to part A. All right, just involved resolving some of these forces, perpendicular and parallel to the plane. Okay, and there we have the answer. Okay, now it says find the time for which the particles are in motion before they collide. Now this is where a lot of students had problems. Okay, a lot of students had problems as mentioned in the examiner's report for this exam. So we have this projected up the plane at 10 meters per second, accelerating at minus 11.6 meters per second squared. We have this released from rest initially, and what we need to do is find its acceleration down the plane. When we've done that, we can proceed to continue. So let's work out the acceleration of particle P. We can do that again by resolving the forces acting on particle P. So you have its weight, you have the reaction force, and now as this is now being projected down the plane, the frictional force in this case is going to be acting up the plane. Okay, so you're going to have F max, you're going to have R, and you're going to have mg. Okay, so similarly, we can resolve the force for the weight. Okay, I'm not going to draw all the things in now. Hopefully you understand what to do. I'm just going to go ahead and just, this is the, let's put it with this, second. Okay, this is the resolving of the weight parallel to the plane. This is perpendicular to the plane. Remember, this is alpha, as we mentioned before. So this is mg times sine alpha. This is mg times cosine alpha. Okay, and F max is mu r. So again, we can't use the same values as before for F max because r is different. So we know that r is equal to this time mg cosine alpha, not 2mg cosine alpha. That will affect the value of the F max. So this is m times 10, that's 10m times cosine alpha. Remember, cosine alpha was 3/5. So it's going to be 30. So it's going to be 10 times m times 3/5. So 30 over 5 is 6. So you can say R is equal to 6m. R is equal to 6m. And we can find the forces acting. Now this is going down the plane. So I'm going to take down the plane as positive. And this time I'm going to have mg sine alpha minus F max equals the mass times acceleration. Okay, so we have mg times sine alpha, which was 4/5. That's going to be 4/5 times 10 times m. So 10 times 4/5, that's going to be 8. So that's going to be 8m minus, and you have F max, which is mu r. Now mu is 3/5. Remember, F max is equal to mu r. So it's 3/5 times 6 equals ma. So you're going to have, and this is going to be 6m, sorry. So the m's will cancel out. So you have 8 minus 18 over 5. 8 minus 18 over 5 is equal to a. So when you do that, what do you get? 8 minus 18 over 5. That gives you 4.4. Acceleration is equal to 4.4 meters per second squared. So this acceleration is 4.4 meters per second squared. So Q is moving up at a speed of 10 meters per second initially, but decelerating 11.6 meters per second squared. A starts from rest and accelerates down at 4.4 meters per second squared. And now we got to find the time for which the particles are in motion before they collide. Okay, before they collide. So now this is where we have to be careful, because it's not like when you throw something up in the air and the only forces acting on it is gravity, and like there's no air resistance. There's no resistance to motion. Here there is a resistance to motion by friction. So for P, it's no problem. It's the same as it goes down the whole time. The resistance for motion to motion will be the same all the way through its motion because it's going down the whole time, P. But Q is going to go up, and if Q doesn't collide with P before it comes to rest, so it might come to rest first and start sliding down the plane. So if that happens, if Q and P do not collide before Q comes to rest, then the situation of Q after it has come to rest is not the same as it was before. Its acceleration will change. Why? Because as soon as it starts coming down, the frictional force will start acting upwards. So as it's going up, the frictional force acts down. But when it comes down, the frictional force will act up. So the acceleration will be different on the way down than it is on the way up. The acceleration will be different on the way down than it is on the way up. And we cannot use suvat for that whole situation. So we have to break this down into two parts. And this is where most students didn't do. First of all, you have to determine, will they collide before or after Q comes to rest? If they collide before Q comes to rest, no problem. We can just carry on and use suvat for both, in one go for both of them. All right. But if they collide after Q comes to rest, we have to break it into two parts. You have to consider the time it took for Q to come to rest as one part, and then for instantaneous rest, where it stops for a second, for just a moment before it starts falling down, and then we got to consider the second part when Q is moving down, and then we got to see from there, and we got to find those two times and kind of add them together. So that's the important thing here for us to determine. Do they collide before Q comes to rest? So this is a bit of a long-winded question, actually. I don't know if the examiners actually intended it to be like this in the beginning, but it's a very tough question. Okay, you got to think a little bit about it. And as the examiner's report mentions, it says, basically hardly anybody got this right. And they had to make a special case for those who just assumed they would collide. And, to give people like 4 out of 5 marks for that. They did that because this question was so difficult in terms of the way you had to think about it. So you have to think about this question quite deeply. So now, this is the situation. This is released at 0 meters per second. This is projected at 10 meters per second. So let's consider, first of all, the time for Q to come to instantaneous rest. Instantaneous rest. That's what we have to do first. Okay, we have to consider how long it took for Q to come to rest, and consider that, and then see, does P reach Q by that time? If it can, then we have to deal with suvat. Then it's easier, but let's have a look. So how long does it take for Q to come to rest? Let's use our suvat equations and see. We don't know S. Let's call that SQ1. We don't know what that is. U is 10 meters per second. I'm going to take up the plane as positive because it is being projected up the plane. V, we want to find it when it comes to instantaneous rest. That's going to be 0. A is minus 11.6 meters per second squared. And T, I want to find what that time is. Let's call it T1. Okay, so we have V, U, A, and T. We can use this nice, easy formula. V equals U plus AT. So the final velocity is 0. Initial velocity is 10. Plus acceleration is minus 11.6 times T. So we end up with T is equal to 10 over 11.6. Okay, because you add this to both sides and then divide by 11.6. So you have 10 over 11.6. 10 divided by 11.6. Which gives you 25 over 29. Let's leave it as 25 over 29. 25 over 29 seconds. Okay, so now we got to find, that's T1. So we got to find now the distance that P moves or in that time. We also need to find how far Q, we also want to find SQ1. So let's find SQ1 now. We could have done this from this as well. V squared equals U squared plus 2AS. Okay, we can find it that way, but we can also now find it by using S equals U plus V over 2 times T. So that's going to be, so SQ1 is going to be U, which is 0, or 10 plus 0. 10 plus 0 over 2 times 25 over 29. So that's going to be this times 5. So we take this value, 25 over 29, and you multiply it by 5. That gives you 4.31 meters. Okay, 125 over 29. 125 over 29, which is 4.31. I'll put it to a few more decimal places. 4.3103 meters. Okay, so that's how far this has gone up. So Q has gone up a distance of 4.3103 meters before it comes to rest. Okay, this is when its speed is 0. We're going to consider P now. So how far does P move? The time for P to come to instantaneous rest. Okay, no. Let's see. The distance moved by P. Distance moved by P in time 1, which is 25 over 29. So for P, we have SUVAT, S-U-V-A-T. We want to find SP1. U is equal to 0 for this. V, we don't know. A is 4.4. We'll take down as positive because it's moving down. So it's positive 4.4. And T is 25 over 29. So we can use V equals U plus, no, we want to find the distance. We can use S equals, we have S, we want to find S. AU, okay, we can use V squared equals U squared plus 2AS. So V squared, no, we can't use that. We don't know what V is. We could use V equals U plus AT, no, we want to find the distance moved. S equals UT plus a half AT squared. Sorry about that. So SP1 is going to be U, which is 0 times T, that's 0. You're going to have a half times A, which is 4.4 times 25 over 29 all squared. Okay, so that's going to be the answer. That's how far P moves down. So you got 25 over 29 squared times 2.2. So half of times 4.4. That gives you 1.634 meters. 1.634 meters. Okay, so this is how far P has moved down in the same time that Q has moved up and come to rest. So I don't think they add up to be more than 6.4. Let's just make sure. That's 1.634 meters. If I take those values and I add them together, I don't think I'll get 6.4. So 1.634 plus 4.3103, and that gives you 5.944. So altogether, that's 5.9443 meters. So the distance between them at the point where Q comes to rest, this point here, is going to be 6.4 minus this amount. So 6.4, take away this amount, that's going to be 0.4557. So this distance here, this is here 0.4557. That's the distance between them at the point when Q comes to rest and P has reached there. Okay, so now we can try to work out what happens in the time that they're going to collide. So okay, so now we've worked out that Q is going to come to rest and then fall down again before P collides with it. All right. So now we've got to consider the new acceleration of Q. Now we know that the acceleration of P down the plane is 4.4 meters per second squared, and Q will have the same acceleration down the plane because it's the same plane and it's the same frictional force. Okay, and we can understand from what we learned that the acceleration will be the same for both of them. Acceleration will be the same for both of them. The acceleration is independent of the mass down the plane. So the acceleration for both of them will be 4.4 meters per second squared as they both go down the plane. Okay, so that's one thing we should understand. Because the friction is going to be acting upwards on Q now, because Q is going to reach this level, and then it's going to start going down the plane. When it starts going down the plane, the frictional force now acts in the same direction as for P, up the plane. So you'll have a component of its weight minus a component of the friction will be the resultant force equals ma, and basically, the two m's will all cancel out from each of them. So you'll end up with the same acceleration of 4.4 meters per second squared as it's going down. We could calculate it, we don't need to. Okay, so very long question. So I'm just not going to bother calculating, but we should understand that it's going to be the same acceleration. So now we have a kind of new situation. So I'll just take this and make a little diagram down here to deal with that. So we have a new situation where they're both moving down the plane. So P has reached a certain level, which is say over here. Okay, and Q has reached a certain level, which is over here. So let's say this is P1 and Q1. New situation, right? Now, they're both moving now with the same acceleration, 4.4 meters per second squared. Both of them, 4.4 meters per second squared. All right, and Q1 is starting from rest. Now, P, if I consider P starting from here, it will also started from rest from the beginning. But this would be at time, let's say T1, the time we found, okay, that would be at T1, this would be basically, we're considering the time it takes for them to collide. Okay, P and Q collide. So this would be the time it takes Q to reach that level plus 25 over 29. All right, the time it took P to reach here. Okay, that's the time that P has traveled to get to here. All right, that's going to be the time for P. You can say T equals the T we're looking for plus T. This is T1, the time it took for Q to reach here. And for Q, it's just going to be from here to here. It's just going to be the time T. Okay, this is going to be if we consider P starting from the beginning here. Okay, the distance it's traveled is going to be basically, let's call this X. Okay, or in fact, let's call this X plus. I'll just call it X for now. P is the distance traveled. Let's call it X. That's how far it's traveled. U is 0. V is the velocity it reaches, which we don't know. VP. A is 4.4. Okay, we're taking down as positive, and T is equal to the T plus 25 over 29. Let's call it T1 plus 25 over 29. And for Q, the distance it's going to travel, okay, is going to be this distance here, okay, which, how can we relate it to the distance that travels? Well, we know that it's going to be, this distance was how much? This total distance was, we can work it out, because 1.634 was the amount that P moved, plus this distance here, which was the difference between them, which was, we worked out as 0.4557. 0.4557. So the distance that S is going to move, let's say the distance Q moves is X. The distance that P is going to move is going to be that same X plus this distance here. So it's going to, by the time they collide, P will have moved this distance plus the distance that Q moved, and Q will have moved this distance. So we add these two distances together. So I'm going to have 1.634 plus 0.4557. That gives me 2.0897. So this is X plus, what was it again? 2.0897. 2.0897 meters. So that's the total distance, the displacement of P as it moves down. By the time it collides, Q has moved only this little x. And the initial speed of Q is also going to be 0, because we're taking it to start from this point here. If V, we don't know what it's going to be. In fact, we probably have to find this for part C, because part C is asking about part C is going to ask about when they collide and the speeds after they collide. So we have to know the velocities before they collide. That's going to be important. A is 4.4, as you mentioned. And the time here is going to be just the t, which we're looking for. That's what we're looking for in this part of the question. Okay, so we have to deal with S and U and A and T. S, U, A, and T. So if we think about that, that's S equals U, T plus a half, A, T squared. Okay, so what we can do here is we can say for P, we have the equation X plus 2.0857 S equals U times T. That's going to be 0 times T, that's gone. UT plus a half AT squared, so you're going to have a half times 4.4 times T1 squared. Okay, which is going to be 2.2 T squared. Okay, and for Q, what's this doing? I don't know. For Q, we're going to have X equals, and again, it's going to be the same thing. It's going to be a half hold on, there's something wrong here. What did I do wrong here? Sorry. Let me correct that. Okay, so for P, X plus 2.087 is equal to a half times A, which is 4.4. A half times 4.4 times T1 plus 25 over 29 squared. Okay, and for Q, you're going to have X equals a half times 4.4 times T1 squared. Okay, so now if we subtract these two equations, the X will be eliminated. We'll have 2.0857 equals, and you'll have this minus that. So you'll have 2.2 times T1 plus 25 over 29 squared minus, you're going to have 2.2 T squared. Okay, so when you expand this, you'll have 2.0857 equals 2.2 times T1 squared plus, you're going to have 4.4 times 25 over 29 T1, because you're going to, when you expand this, you're going to get 2 times this, then you have to multiply by 2.2, and you're going to have plus 2.2 times 25 over 29 squared minus 2.2 squared. 2.2 T squared, these cancel out, so we're left with basically all of this. So if you solve this, you have 2.0857 minus 2.2 times 25 over 29 squared, okay, equals T1. So we have to divide all of this. A bit of a mess here. But anyway, we'll just continue over here. Divided by this, which is 4.4 times 25 over 29. So hopefully this will give us the right answer. It's a very, very nasty question, to be honest. So we're going to have the last answer. Okay, minus 2.2 times 25 over 29 squared over 4.4 times 25 over 29. And that gives you 0.1198. 0.1196 seconds. So that's T1, which is basically the time, this time here. Okay, so we need to find the total time. So we have to add 25 over 29 to it. So therefore, the total time is equal to 25 over 29 plus 0.1198, which gives us plus 25 over 29, which gives us 0.9819 seconds, 0.9819 seconds, okay, which is going to be, so the time is equal to 0.982 seconds. And that's actually the correct time. But what a palaver that question is. A very long-winded question. So far, we haven't even finished yet. Actually, we've got to do part C. But that is the answer to part B. Okay, it's very complicated, actually, to be honest with you. And I don't know how many students would have actually got the time to finish it. As you can see, it's taken up much more space than we were given. I had to move around some of the questions here. Okay, even this is, well, the next page I think is the additional page. So we have to do part C on the additional page. Okay, where is part C? It's down here somewhere. Okay, so there's part C. So now we're ready for part C. It says the particles coalesce on impact. So now, oops, go this way. The particles coalesce on impact. So now what we have to do is we have to consider the velocities as they reach this level. So I'm going to take this information here. Okay, I'm going to take this information here and I'm going to put it on this side. Okay, I'll put it over here. Okay, so we need to find VP and VQ. Okay, and we can do this V equals U plus AT. We know this total time now is the time that we found here, which was 0.9819, 0.9819, and we know that T1 was equal to, we found it here earlier, 0.11988, 0.11988. Okay, that was this time here. So we know the times that they'll be moving for. So we could use for P, we can use V equals U plus AT. So VP is equal to U, which is 0 plus A times T, which is 4.4 times 0.9819. So that's going to be how much? I'll just use these values. So 4.4 times 0.9819. That's going to be 4.3203 meters per second. And the velocity of Q is going to be V equals U, which is 0, plus A, which is 4.4 times 0.11989. So that's going to be 4.4 times 0.11989, and that gives us, whoops, 0.1198. That gives you how much? 0.5275 meters per second. Okay, so now we have the velocities that they've reached at the point at which they collide. So we want to find the velocities after the collision. So this is M, P, and this is 2M, which is Q. This is going in this direction at a speed of 4.3203, and this is going in the same direction down at 0.5275, and this is before the collision, and we want to find out what happens after the collision. Okay, this is before, and we want to find what's happening after. After they have one mass, which is 3m, and one velocity, which we don't know which way it's going. Well, obviously it's going to go down. We've got to find that. So let's use conservation of momentum. So before we have m times 4.32, we'll take down this way as positive. 0, was it 5 or 3? 0.3. Sorry about my bad handwriting here. plus 2m times 0.5275. And that's equal to the total momentum after the collision, which is 3m, because they coalesce, they become one particle, so their masses combine, times v, which we want to find their final, the velocity after the collision. Just get rid of this, copied it in case I needed it. So now we can say that the m's will all cancel out. So it's going to be all of this divided by 3. So we're going to have, let's just work it out. So we have this times 2. This times 2 plus 4.3203. Okay, and we have to divide that by 3, which gives us 1.791. So the velocity after the impact is going to be, where is it gone? 1.79177, 1.79177 meters per second. So it's going to be, the velocity is equal to 1.79 meters per second. That is the speed of the particles after the impact. Okay, so speed is 1.79 meters per second after the impact. So there we have the answer to this nasty, nasty question, okay, which took a long time. And anyway, we've got through it, okay, at last. And a lot of different things involved in this question. I hope you understood what I did. Other questions from this paper can be found in the playlist on the top right of the screen at the end of the video. Other questions from the topic of, now what should I say about this topic? This topic is to do with inclined planes. I'll put something there for inclined planes. Dynamics, okay, which is like SUVAT. And I'll also put momentum, okay? So different playlists will show up, which give you like exposure to other questions on those topics. Thank you for watching and see you soon.